All right, let's deal with a tough one. Like this is a lot. It's actually helpful that we have bounds on this one. So here's our little helpful thing corresponding to our substitutions. And oh my goodness. Sorry, I ran through this problem already and I made a silly mistake. At like minute 11, so I had to start back over. Oh! So we have some bounds from 0 up to 3 times the square root of 3 over 2. And we have x cubed divided by some garbage. All right, so this is worst case scenario. You probably just pick up a step, but I'm going to move quickly, or this problem's going to take like 20 minutes, and I don't want it to take 20 minutes. So we're going to choose a substitution. Now, clearly we have a squared plus a number, so we're going to use tangent. So x is equal to something times tangent of theta. And we got to figure out how to create something that when we multiply it by 4, it's going to equal 9. So we want 9/4. 9/4. But we don't want 9/4 because we're about to square it. So what's the square root of 9/4? 3 halves. Therefore, dx is equal to 3 halves secant squared of theta d theta. Now let's change our bounds. Let's just do this before we ever get started so we never have to go back to x's. So when x is equal to 3 root 3 over 2, we set that equal to that 3 halves tangent of theta. The 3's cancel, the 2's cancel, and we just get the square root of 3 is equal to tangent of theta. Knowing that we're either in the first or the fourth quadrant, well, we better be in the first, so theta, we know that tangent of pi over 3 equals root 3. Yeah, we already know that, so that's no big deal. So there's our upper bound, pi over 3. And then we're going to need to use x is equal to 0, but there's nothing to do here. 0. It's 0. Tangent of 0 is equal to 0, and 0 times anything is 0. So, all right, there's our bounds. Now let's go through and start replacing everything. And again, this is a worst case scenario. So we're going to take our top and we're going to cube it. So that's your 3 halves tangent of theta. And then down below, we have something to the 3 halves power. So we have 4 times 3 over 2 tangents of theta squared plus a 9. But oh, nope, we still have our, we have more stuff to do here. We still have our 3 halves secant squared of theta. Then there's our d theta. Look how beautiful that is, huh? Oh my goodness, huh? All right, so we have 0 to pi over 3. So we're going to cube everything up. 3 cubed is 27. 2 cubed is 8. We have tangent cubed of theta times 3 halves secant squared of theta. There's our numerator. Now when we square up in the bottom, we're going to end up with 9 tangent squareds of theta plus 9 to the 3 halves power d theta. And like I said, I'm moving quickly. Let's take our numbers from the top and pull them out. 27 times 3, I believe to be 81. 8 times 2 is equal to 16. So now we're left with a tangent cubed of theta secant squared of theta up top. And then what's going to happen down below? Well, we're going to get 9 to the 3 halves power, and that's going to leave us with a tangent squared plus 1, which is equal to secant squared of theta. But this is all to the 3 halves power. I hope you caught it. I hope you caught it, but I gotta go quickly through this. Now, 9 to the 3 halves power is 3 squared to the 3 halves power. The 2's cancel, leaving you with 3 cubed, or 27. So we can yank that out to the bottom. So we have 81 over 16 times 27. Don't worry, the 81 and the 27 are going to cancel out nicely. So we're left with tangent cubed times secant squared all over. The 2's cancel, leaving you with a secant cubed down in the denominator. Let's clean those numbers up. 81 divided by 27 is 3, so you end up with 3 over 16. The integral from 0 to pi over 3. Secant squared is going to cancel with that, and it's going to leave us with tangent cubed of theta over secant of d theta. Let's change everything into sines and cosines, huh? See what we end up with. So that's sine cubed over cosine cubed divided by 1 over cosine of theta. So we'll lose that and become a second power. The denominator goes away, so we're just left with sine cubed over cosine squared. Whew. I know I say it a lot, but so you wanted to be a STEM major, huh? Okay. Whew. We're finally here. Shoot, this problem's tough enough. But hopefully we got some skills. We built skills from that last section. Telling us we're going to need to do some sort of U sub here. So, but we're going to need to break it up a bit because this cosine squared, that's not very helpful. Let's do it like this. Let's call this sine squared times sine of theta all over cosine squared of theta. And this is going to be our du. So let's change this into 1 minus cosine squared. So 1 minus cosine squared of theta all over cosine squared of theta. Oops, forgot my sine of theta. And I'm just breaking it off to the side so we can see it a little bit better. All right, now let's choose u to be cosine of theta. Du will be negative sine of theta d theta. Let's bring that negative back on over. And now we can do our substitution. But we're also going to need to change our bounds so we never have to go back into terms of theta. So we're going to get negative 3 over 16. I'll write the bounds in a second. So we have 1 minus, and this is going to be u squared. That's going to be a u squared. And then our sine theta d theta, well, we already put our negative out to the front, so this is just du. Now let's change our bounds. So when theta is equal to pi over 3, u is equal to cosine of pi over 3, which is equal to 1/2. When theta is equal to 0, our lower bound, we get cosine of 0, which is equal to 1. Now we no longer have to go back into thetas. We no longer have to go back into x's. So let's do, first thing I'm going to do here, I want to flip the bounds and change the sign. Notice that there's a negative. We have a smaller number on top of a bigger number. Let's just change it to a positive. Let's put our 1 up top and our 1/2 down below. Yeah. Now let's break up the gosh darn numerator and get 1 over u squared. Minus u squared over u squared, that's just 1 du. Well, let's change this to u to the negative second power. Can you see we're almost done? We are almost done. So we get 3 over 16 times. All right, so we're going to add 1 to our exponent. And then we're going to divide by that number. Just call it negative. And then we get a u. Evaluated from 1/2 to 1. Well, that negative, there was no choice. It just ended up in there. Let's factor out that negative, and we get negative 3 over 16 times a 1 over u plus u, evaluated from 1/2 to 1. All right, there we go. So negative 3 over 16 times. So 1 over 1 plus 1 minus 1 over 1/2 plus 1/2. Negative 3 over 16 times, so 1 plus 1 is 2, minus, let's bring it in, do one of these. So that's 1 divided by 1/2 is 2, minus 1/2. Cancels. So we get negative 3 over 16 times negative 1/2. We get 3 over 32. Oh my goodness. Let's look back. There it is. There's all the work in order to solve this problem. I mean, I could probably do it in Two less steps? 2 less steps. But these are all the steps that would be needed. Oh my goodness. Calc 2, y'all. So I figured that's a good way to leave you. Maybe I'll do one more. I get another funky problem that, maybe we'll check it out. So, all right. See you in the next one.